Hello, friends. Welcome to this segment of the Embedded Insiders podcast, our weekly podcast all about everything embedded, exciting, and designing in the entire embedded computing space. I'm Ken Briodagh, editor-in-chief of Embedded Computing Design, and I'm very excited to be here with Tom Gall of RISC-V International. Welcome, Tom.
Thanks, Ken. Happy to be here.
The pleasure's entirely mine, and as they're about to find out, our listeners or viewers, now that we are a video podcast.
Ooh.
Uh, Tom, you want to tell the folks a little bit about yourself and your background in case they're not familiar with you?
Sure. So, of course, I stepped into the role of Vice President of Technology here at RISC-V International. But prior to that, I started my career at IBM. So, probably most notably, I was a member of IBM's Linux Technology Center for a number of years. I was the chief architect of IBM's embedded Linux program for a while. So we shipped embedded Linux and all sorts of fun things. Actually, there was a time where you couldn't turn on, certain computers without an embedded Linux actually booting first, so which was kind of cool. So I did IBM for 20 years, and then after that, I went to a company called Lenaro. And so Lenaro, of course, was all about the ARM ecosystem and getting a number of companies to get together, collaborate, and make that software ecosystem strong, at least when it came to open source software.
So x86, then ARM, now RISC-V.
And PowerPC was also in my past, and I will fully admit I was a very big fan of the Motorola 68,000 series as well.
Every now and again in these tell me about your past and your bio discussions, I flash the old Aslan quote, do not quote the dark magic to me, which I was there when it was written. I was talking to somebody about Prodigy Online
Oh
a
yeah.
couple of weeks ago about text-based internet and how we were all sort of just writing, describing things instead of having pictures. It was a interesting time.
Oh yes, yes. And downloading floppy images over a 1200 or 2400 baud modem in there, or even 300 in the early days. Oh,
Oh yeah.
oh,
Yeah.
what an experience.
Really stretching the capabilities of my Commodore 64 back in the family room. um, so that's enough about the past. Let's talk about the right now and the future, Tom. What I mean, you've just come into the role here at RISC-V International. RISC-V has been doing some really exciting things in a lot of different areas. What are you excited about? What are some of your aims and goals going to be?
Well, there's a few things that are just percolating that I think is going to make 2026 pretty exciting. So first and foremost, I think the thing to probably impress on everybody is there's RISC-V International. We're more like a standards organization, right? We have this wonderful ISA that's been designed over the years, and then over time we've seen extensions that have been added to it, like vectors and other kinds of purpose optimized opportunities for companies to go and pull it into their IP and make a great device for embedded systems or even other computing solutions. And the fun thing that's going to happen in this next year is RISC-V International has become an ISO submitting standards body. So this means that the RISC-V ISA is going to become an ISO standard here in the not too distant future.
Wow,
So, having this worldwide thing that is an ISO standard is pretty darn cool. And
that's
then of
very
course,
cool.
yeah, yeah. And then of course, then the next thing that you have is okay, so your standard. Well, what can you do with the standard and what's going to happen? And so for us, there's really a few things which in 2026 are pretty exciting. So we've got this profile that we released as a spec called RVA 23. And so of course that happened this year. There's going to be a little tweak to that called RVA 23.1, but it's not a big change. Besides, there's some necessary things that you want to change and improve, right? You know, as we go into the future, we want things to get better, and that's how you do that. But the fun thing is then when you have a profile like this, which is all about sort of uniting the software ecosystem so that you can have these binaries that work commonly across all of these systems that are RVA 23 compliant, and you can have single binaries that boot on multiple different machines, all that kind of great stuff. So you get some great commonality going. Well, you need hardware. And when's the hardware going to start to show up? Well, it looks like it's going to be in 2026, of course.
Yeah.
And well, I can't pull out the crystal ball and tell you exactly this company, and this company are going to be shipping on such a day, because wouldn't that be fun? Oh, no, no, no. But as people are going to start to see, there's getting to be more and more announcements of, either
Yeah.
dev boards or systems that are showing up that are basically going to be RVA 23 compliant. Even, in 2025, we'd see systems and, vendors pop up and just say, hey, we're designing this thing. It's going to be really awesome. And it's going to be RVA 23s. So this 2026, I think, is going to be a lot about RVA 23 and the hardware that goes
Yeah.
with it.
That's huge. I mean, that's really, really cool. The conversion or not conversion, but the adding in the capability and doing the standards body piece as an ISO is exciting. That's really, really cool. That process must have been complex in getting that all put together.
It is because you're coming in from something that you've been authoring as a standard spec, but not united with a standards body. So you kind of got to get with the
Yeah.
times and go, okay, well, what was the proper process, and how do you change yourself so that you kind of retrofit and fit in?
Yeah,
Um,
absolutely.
and then
That
there's another thing that for the embedded space that people are going to be interested in, and that is
sure.
we've got another profile coming that we're starting to work on called RVM for
Interesting.
MCUs
Okay.
and things like that. So this, we'll see how long this percolates and takes, the various smart people in the room that form the committee
Yeah.
to pull together this profile. But that is one of the things that's going to get worked on here early in 2026, and it would be awesome if we can get it out this next year
Well,
too.
can you tell me anything about it? What are some of its intended targets? I mean,
Yeah, it's really down for the embedded space. I mean, we're really,
yeah.
you're talking MCUs and things like that.
Oh,
Um,
okay.
So
That's
yeah,
awesome.
the Zephyrs and all the other RTOSs and things like that probably should be able to take advantage of it. But yeah, we'll see where
Yeah.
it goes. Because the thing is remember, you got a bunch of smart people getting in the room, and they're going to impose their vision of what they think sort of, you know, what this M profile should be all about. So,
Yeah.
people can get creative, and that so will result in something
Absolutely.
awesome.
So the big story in the North America RISC-V Summit in 2024 was automotive, and then all through 2025 there was a lot of development in RISC-V for automotive, and not that that's
Yeah,
the only place, but that was a big story. And
yeah.
is that still sort of a big leading front for focus for the organization? Are you um focusing on other verticals, or are there some other big stories that folks should be paying attention to with RISC-V?
Oh, so okay. So in the case of automotive, we've got an automotive SIG that's come together. And so, the idea is, of course, RISC-V International, we're a membership-driven organization. So,
Yep.
we've had a number of companies come together that are, of course, all engaged in the automotive space. And so, one of the things what they do when they initially get together is they say, where's the gaps? What's missing? What's not quite right? What could we do here? And so they
Hmm.
they they started start looking at things with fresh minds. The other thing that they do is they also look at all the other kind of complementary committees that are within RISC-V that sort of are utilized within the automotive space. So, for instance, we've got oh, so we've got a safety. Uh, I'm fumbling over the word. so, so we've got a functional safety SIG.
Hmm.
It's missing the F.
Yep.
And we've got trusted computing, we've got a server SOC committee, we've got a hypervisor committee, and runtime integrity. So these are all kinds of things that are deeply important to automotive. So they don't necessarily have to take on those tasks within the particular committee. You can kind of string all of this together, sort of whisper in people's ears and say, hey, we need this for automotive too, and make sure that as they're working in their own respective spaces, that then it also takes into account what automotive needs.
Yeah,
So
I mean, it's not like these um technologies aren't cross-platform and cross-vertical in some ways. And a
yeah,
hypervisor is a hypervisor, so long as it meets the requirements, for, broadly speaking, right? I mean, that's fair to
yeah,
say.
yeah, it is. I mean, and the thing is that what might be a great hypervisor for, say, like a hyperscaler or, sort of the, kind of cloud computing environment, and what you want to do for a car, they can be a little different, but that's okay. I mean, there's definitely
Sure.
areas of technology that are overlapping. You're quite right that, what is good for one can oftentimes be really, really good for the other.
Yeah.
Um,
A lot of the broad speaking news has been AI, especially at the edge. Risk
Yes.
Five's always been sort of very good at edge management and stuff. So I assume there's still a lot of focus happening on that front.
There is. And so I think there's kind of a couple of really interesting conversations to have here in this space. So one of which is, you see RISC-V cores already in GPUs today. In addition to that, there are RISC-V cores which are being sort of crafted into sort of custom designs that then companies are shipping as accelerators. So
Yep.
black hole, for instance, is one of them. So look it up. It's a fun one. Just do RISC-V black hole. Google is your friend, as they say. And um, and then the other kind of fun one that I'll note too is that there was one that was done by Meta, and so it's called MTIA. So there's a couple of they did a blog post, they did a paper back in, I think it was 2025, 2024. It was one of the twos where they kind of talk about this architecture of
Hmm.
how do you take a bunch of cores, enable AI algorithms where you maybe want to load the data but not move the data, and allow the cores to be sort of different parts of the algorithm.
Hmm.
And so, again, as a way to kind of, accelerate things. So there's a lot of innovation kind of going in this space. I was recently at Supercomputing down in St. Louis a few weeks ago, and there was a really interesting sort of tension in the background. So these are all folks that work in high-end systems. If you think about it, these data centers that are getting built across the United States right now, or across the world, they're really all high-end supercomputers in one respect or another.
Yeah.
And so across these high performance computing spaces, the thing that people are, sort of realizing is that you sort of have this one-to-one relationship where if you want more computing power, you add another GPU, you add another machine. And so it's a one-to-one relationship, which also means that you increase the amount of electricity that you're consuming.
Yeah. Yeah.
And so where they've sort of kind of come to this realization is, hey, wait a minute, we're going to hit bounds because we can only build these things so much, otherwise you're just consuming crazy amounts of electricity and stuff like that. So the tension is can we come up with something different or better that's more effective for how you do computing and AI and sort of on these high-end systems? And
Yeah.
so, is that GPUs? Is that not GPUs where you string a bunch of purpose optimized cores together, like what Meta has done with RISC-V? Good
Hmm.
question. Nobody knows yet, but that is state of the art. And that's part of the fun here. And it's great to see
Yeah.
that RISC-V is kind of involved on both sides of the fence.
Well, I wanted to dig into that a little bit because obviously, as you mentioned, one of the big issues facing computing in general and the AI space specifically is energy use. As
Yes.
the servers get bigger and more powerful, they're using a ton more energy. I think I saw recently that if not now, soon a quarter of the world's energy will be going into AI. Broadly speaking, what some AI purpose.
Yeah.
Um,
Yeah.
and also water for cooling. And I feel like, and I'm not the expert, you are, so I'm going to ask you. I feel like RISC-V has some advantages to offer on both of those fronts in terms of the flexibility in design and things like that to be energy efficient and potentially to have more easier methods or different methods to manage heat. Can you
Right.
tell us a little bit about that side of this?
Yeah, so when you get into down to this part of the design, it really gets to be vendor specific because, as a vendor is trying to, target a particular part of the market, be it, more on the embed or edge or, again, in, something that's a data center, they're going to make specific kinds of choices.
Yeah.
And so in the RISC-V world, so now I'm gonna take this somewhere where it's future looking.
Yeah.
When it comes to AI in general, we have actually three efforts going on right now as far as how do we accelerate things. So right now, current state of the art is you've got RVV, which is all about, kind of vector computing and so as a result, part of the ISA has been extended to do vector computing, and that helps AI to a certain extent, but it can be even better. And so we have IME, VME, and AME that are all kind of percolating in amongst the committees as far as how can we accelerate and even be more efficient as in these AI environments. And so the difference between these three is IME is all about doing more matrixy kind of math, but using the current vector register files that have been created. So it's kind
Hmm.
of just extending it, but taking it a little bit further. VME then adds accumulators that would be specific for matrices. So you're still using register files, but you're sort of just mixing in a little bit more for the accumulators and kind of some of the things that you do with matball and all that kind of good stuff. So hand
Yeah.
wavy, hand wavy, hand wavy. There, we won't get into the deep math. But then there's AME, and so what that does is that introduces the concept of register files, which are matrices themselves. So it's not using the vector register files, but actually introducing whole new ones. And so the thing is depending on which one of these three that you as a vendor might choose in the future, you are going to use more real estate on your silicon, for something that's more high end, but then maybe you're targeting something that's, cloud computing or, really cutting edge, or maybe you want to you choose like IME. And so that's something a little bit more maybe modest as far as, what it's going to take up and, uh, what ultimately you'd get for a profile when it comes to power and all kind of good stuff. So,
Yeah.
this is where the brains in the room are again trying to turn the crank in innovation, to come up with something that again is going to hopefully meet these power profiles and make it better.
Yeah. It's a really important but interesting problem.
It
It's
is.
one of those ones where for years I've said that the I expect the big next innovation to be batteries. We've been sort of stuck on battery for a long time
Yeah.
with like we know how to make pretty good batteries, but we haven't moved to phenomenal batteries, crazy, infinitely rechargeable, whatever the version of a battery would be, or something that doesn't lose energy over time. Who knows? Whatever the innovation is. Um, I'm shocking no one, I'm sure. I might be wrong that the next big innovation might actually be um, in this kind of efficiency of energy use rather than storage. Um, but I'm still going to claim partial credit for being right about it being energy. So,
Well, there you go. Claim that credit. Yeah, and it is a bummer that, battery improvements, they're like 5%, 10% here and there, as
yeah,
opposed to, 2x or something along those lines. But
right,
I
right,
I
right.
think you're right. We've got to get more efficient. And, you know, hey, we've got this brain thing, and it's a pretty
Yeah.
efficient computer, and it's not like it's running at a gigahertz.
It's an interesting that's such a good point. Like it's possible. We can see that it's possible. So I'm looking forward to biomass flavored batteries coming up. Um as we're getting near the end, we're getting to my favorite part of these conversations and the most fun part, where I get to sort of give you the microphone metaphorically, and say, what are you excited about? What's the part of this the the joining RISC-V and the RISC-V space that sort of gets your engineer brain churning and that you're excited to get your hands dirty with or see where it goes.
Yeah, yeah. So I think the thing that's most exciting about RISC-V International is we kind of have this philosophy where it's, you have both great hardware and great software. You have to have both to be super successful.
Yeah.
And, for us organizationally, we have RISC-V International, which is sort of all about the hardware and kind of where are we taking that and, enabling a future set of vendors to come up with future cool products. But then we also have this sister organization called Rise, which is all about the great software side of things. And so
Yeah.
we sort of work hand in hand and, whisper in each other's ears and like, hey, could you do this? Hey, you might want to, take advantage of this new cool feature which is coming.
How dare
And
you
so
suggest that software and hardware work together?
who knew? Who knew? But the point being is that in order to make these kinds of things happen, you have to have collaboration, and that collaboration happens on many different levels. So there's collaboration on the designs and where you can take the ISA in the future, or the specs that set next to those ISA extensions. And maybe it's something in boot, maybe it's something in debug. We've got security. There's a whole bunch of things that are just kind of noodling around. And the great thing is in RISC-V International as well as in Rise, there's a great set of brains that are gathering around the table doing cool stuff on a day-to-day basis. And it's resulting in some pretty great things for us to talk about here today and tomorrow and all that kind of good stuff.
Absolutely. And my last question is always the same. What didn't I think to ask you, because I don't know any better, that I should have, that we should definitely let the engineers listening know about?
Okay, well, I think the thing that I would pass on to engineers, at least as far as a question, if you will, is a sort of how do you collaborate with us? How do you get involved? So and the great thing is there's a number of things that are coming up. So one of which is we've got RISC-V Summit happening in June. So this is going to be over in Europe. So that's kind of the next place to come together, and that still being planned right now, but it looks like it's going to have some very strong hardware tracks as well as very strong software tracks.
Nice.
So we'll be getting out the call for papers and all that kind of good stuff. But then just even in general, I mean RISC-V International, it's pretty easy to join. It's very easy to attend our meetings and things like that. We've got all these mailing lists and things like that. So uh, RISC-V.org, just go there. That's on the website. You can go and jump into our wiki and into our mailing list, all that kind of good stuff. So yeah, pretty easy to get involved.
Absolutely. And I think all the engineers who are all reasonable people would agree that there's enough room in the marketplace for whatever your IP is, whatever you want to do. They all have their own use cases, and even when they overlap, there's enough room for everybody. So get versed in RISC-V if you're not already. Get involved in the RISC-V International organization. And thank you so much, Tom, for joining me today. This has been a lot of fun. It's nice to
Thanks.
chat with you.
Thank you, Ken. I really appreciate the opportunity. So
The pleasure's mine. And folks out there listening, thank you so much for listening to Embedded Insiders. Make sure that you subscribe to us on all your favorite podcast platforms. And if you're watching us here on YouTube, hit that subscribe button, like us, share us, do all the things so that everyone out there in the engineering community gets a chance to, at the very least, hear what Tom has to say, if not me. Thanks, everybody.